So as I was working on the issue, I looked at the thread dump. And there I saw something interesting. What I saw was these bunch of threads waiting on the same object. And among them was this finalizer thread. And when I look at the stack trace, what I saw was the application threads were actually waiting on finalizer class. And it was actually instantiating an object. And during object instantiation, it was doing something with respect to finalizer class. And I had no clue what it is doing. So I started researching about finalizers, and I found quite a deal about finalizers. And I'm here to share that experience and hopefully be able to explain the performance implication of finalizers. But before we continue with my story, let's set some background first. So what is Finalizer? Finalizer is a class on object. It's a class called Finalize. And it's a way for your application to tell garbage collector, hey, garbage collector, before you reclaim my object, please do this first. And garbage collector calls that method for you, the finalize method for you, from a background thread, which is called Finalizer thread. And it's usually used to do post-mortem cleanup. So if you have like a file handler you want to relinquish after you are done with the object, you can put it in finalize class. And here's what happens when an object gets instantiated. So first thing that JVM does is it checks whether the object is finalizable. And the way it checks is by looking at the class if it has an overridden finalize method. And if it finds out that the object is indeed finalizable, it creates this new instance of type java.lang.ref.finalizer and associates this original reference as a reference. And then what it does is it registers this new class as a static variable in Finalizer class. And then your object plays in application lifecycle. And once the object is done, GC runs sees, OK, this object is no more referred from anywhere else, but is still referred from Finalizer class. In which case, what it does is it adds the object to this queue. And this queue is processed by this background thread. And what it does is it picks an object from the thread, call finalize method from the object, and then deassociate it from finalizer class. So next time GC runs, sees, OK, object is no more referred from anywhere else and is also not referred from finalizer class. Now I can kill it. So it takes at least 2 GC cycles to reclaim a finalizable object. And that is just one of the problems. So coming back to our story, when I look at the finalizer thread and finalizer class in the stack trace, I kind of started figuring whether this is my root cause. And one thing I also noticed was we had finalizers used heavily in our application. There was a pattern where like finalizer were written all over the place. But I wanted to get some numbers behind my hypothesis. So what I did was I did a benchmark. So I used JMH for my benchmarking. It's short for Java Micro Benchmark Harness. It's an awesome tool for benchmarking. And I'm not going to cover the source code for benchmark, but it's available through my GitHub repo, so check it out. And when I ran it on my system, what I found out was the average time per object creation was up to 7 times to 600 times slow for finalizers than for non-finalizers. And where this time was going? It was mostly going in doing GC. What I found out was the GC time for finalizer benchmark was 50 to 200 times more than non-finalizers. And the allocation cost per object for finalizers were 3 times more than non-finalizers. And so just imagine, just by adding a minute method in your class could actually start costing you 3 times more for your objects. So it has a huge implications. But when I found out these numbers, I was kind of sure that this is my root cause. But then the other challenge for me was to make this change. And we had these 50 plus classes which has finalize method overridden, and all they were doing was like setting this member variables to null most of the time. It's like somebody is on his deathbed and you are coming to claim his state. It's cruel. So don't do that. So what I did was I actually changed this one class which was heavily used. And then I thought of running some load test. So this was the baseline. Before my change, when I ran the load test, I captured the performance metrics, and this is actually Dynatrace that I used. And what I saw was the garbage collection time was, this yellow part was approximately 5% of the total execution time before my change. And after my change, guess what? Garbage collection didn't happen. It happened, but like it's minuscule, so it's like hardly visible. So that gives me confidence, and I put this change in production, and I'm glad to report that after we put this change in production, we never have to restart the server in peak hours. So as we see, finalizers are not only bad, they can actually bring down your application performance to its knees. So let's talk about the problems. And Joshua Blow, in his book Effective Java, actually kind of condensed the problem in this simple sentence. Finalizers are unpredictable, often dangerous, and generally unnecessary. So dead object resurrection is kind of the root of all evil with the finalizer. It's because of this, JVM has to handle finalizable object differently. And it is the fact that finalize method can accidentally or intentionally resurrect an object from dead. Like in this class, we have this static reference. And what Finalizer is doing is giving this pointer to the static reference and making this object live. And that can happen, and JVM has to handle it. And the way it handles it, it runs GC, sees Finalizer is no more in use, adds it to the queue, call finalize method on the object, and then GC happens again. It checks, OK, finalize method is called on the object, and object is not resurrected. So that's why it takes 2 GC cycles to claim these guys. And then, as we see in the benchmark, it increases the allocation cost. And not only allocation cost in terms of memory, it also increases the allocation cost in terms of CPU utilization. Because when finalizers are created, you have this new instance of java.lang.ref.finalizer also getting created. That increases your memory utilization, and finalizers are actually finalize method is called from the finalizer thread, which is going to share resources with your application thread. So if finalizer thread is doing too much, then guess what? Your application thread will suffer. And this is where things started getting ugly. Finalizers can cause more GC. Just by the fact that finalizers are held up in memory longer, at least 2 GC cycle, and when I say at least, it could be 2, 3, 4, many. So what happens is they can limit your allocation space, and if you have limited allocation space, guess what? You'll have more frequent minor GCs. And when you have these objects held up longer, there is a possibility that these objects will get pushed to old gen if you are using generational garbage collector, and most of us does. So what will happen that you might hit a full GC, and you would never ever want to have a full GC when users are accessing your system. It can take pause of several seconds, even several minutes sometimes. And then there is no guarantee when finalizers will be called or if it will be called at all, as there is no guarantee in Game of Thrones who is going to survive this season or this show. So this is where things actually gets more ugly. Like what will happen is if you are doing any time-sensitive operation in Finalizer, there is no guarantee if it will be called immediately. It means it might be called several seconds, several minutes later, as it's done asynchronously. And also, there is no guarantee which order they will be called. So for example, here, what we have is we have this output stream wrapper, which has a reference to a file output stream. And when the parent object is going to be available for garbage collection, the stream object is also going to be available for garbage collection. And stream also has finalize method. So what will happen if stream finalize method is called first? You'll come here, stream is already closed. You'll get an exception. And what happens if there is an exception from Finalizer? It will ignore everything else. So if you have anything else after that, let's say if you have a native memory you want to deallocate, it won't be called. It not even be reported. Like with Finalizer, one of the other problem is it won't be even reported in your log. So if there is an exception, it will be totally ignored. And this could be your Finalizer thread, blocking everyone else. Though Finalizer thread are low priority thread, like what I found out in our application, that the for JBoss, the worker thread has priority of 5, and Finalizer thread have priority of 8. So Finalizer thread are actually a little higher priority than my worker thread. So these kind of things can happen. Means if any object which has finalize method overridden is a multi-threaded object, because finalizers are called from a separate thread, and that's where not where they are created. So you can have these concurrency issues. And sometimes finalizers are called earlier than you think. Like here, this code can be optimized by compiler to convert this dot stream into a single load. And after this line, this is not going to be in use. And what will happen is if GC happen, actually this object can get garbage collected. And finalize method can be called, and what will happen here? It will blow up on you. So these kind of things can happen. It won't happen very often, but it will happen. And what you can do is you can put a synchronization block around it, in which case your stream finalize method will wait because this will have a lock on the stream object, in which case you'll be safe.
Can you explain that last slide a little bit? Because maybe this object gets dereferenced?
So what happened is a JIT compiler has several optimization that it does. And one of the optimization it does is it can actually convert, if you have multiple calls of the same object, it can convert it to a single load and kind of cache it. So this dot stream can be actually converted to a single load, and then in this case, this is actually not going to be used in the second line. So it will directly use the cached object and call write on it. And then finalizers are bad, right? They are terrible. So why would you ever use it? Unfortunately, there are certain scenarios where there is no better alternative. And one is where you want to deallocate a non-memory resource where it's hard to predict the life cycle of the object. Like if, for instance, object is created through a callback method from a framework, you don't know when it will be called or when it will be deallocated. And where there is no time criticality, means you never want to do a time-sensitive operation in finalize method. And the other case is where you want to have a safety net if you have provided an explicit cleanup method. For instance, if you want to deallocate a native memory that you are using, which is associated with your object, and you have provided this cleanup method, but client forget to call it, in which case you have this safety net. But it's very important to actually log that as an error so that the client will know that they forget to call it and they go and fix it. Now, let's talk about some of the pitfalls that you can avoid with Finalizer. One is, if you don't have to use it, don't use it. Don't try to help GC like this. And if there are other lifecycle methods available, use it. Like for servlet, instead of having finalize, you can pretty much use destroy method for that. And provide explicit cleanup method. If you have control over who is going to call and when they are going to create an object, you can provide an explicit cleanup method and do your cleanup there and tell your client to call that. And if you are using Finalizer, it's a good idea to avoid heavy objects with Finalizer. What can you do? You can do kind of Java normal database normalization stuff. So put bare minimum, which is needed for Finalize, in your Finalizable class, and everything else in a different class, and then refer it back from the other class. And Finalizable objects are expensive, so cache them or have a pool of them and reuse if you can. Then these are some of the references that I followed, and they are good read. I have the link to my GitHub repo also. I've put all the examples and some nice graph and chart with benchmark. And to conclude, Finalizers themselves are not bad. Means the way they are used underneath and the garbage collector, the way it handles is what makes it bad. And that had me thinking that we as a developers has to work under the abstraction created by languages, by frameworks, by runtime. And that makes it very important to sometimes look under the hood and see how things are done, how frameworks are doing certain things. It not only makes us a good developers, it also helps us like tune to system strength and avoid the weaknesses. It doesn't mean it comes out naturally. It means for me, the challenge is the more I look, I found out there is more to look. So, but I think like Han Solo from Return of the Jedi, I think I'm getting better. Thank you.